Welcome back. We are still on the topic sequence and series. In the previous video, we solved a question on finding the number of a term in a GP when the value of the term has been given to you. In this video, we are going to solve a question on finding the common ratio of a GP. The question for this video is, if 3 minus a, 6, 7 minus 5a are three consecutive terms of a geometric progression or a GP with common ratio r greater than 0, find the value of a. So 3 minus a, 6 and 7 minus 5a are three consecutive terms in a GP. This means that 3 minus a, 6 and 7 minus 5a are three terms that follow each other in a GP. So for example, in this GP we have 2, 4, 8. So we can say that 2, 4, 8 are three consecutive terms in the GP. They follow each other. The same way, 3 minus a, 6 and 7 minus a are three consecutive terms in the GP. We are being told that the common ratio r is greater than 0. We should find the value of a. We have learned that the common ratio of a GP can be found by picking a term and dividing it by its preceding term. So for example, in the GP 2, 4, 8, we can find the common ratio by dividing 4 by 2. So 4 divided by 2 will give us the common ratio, which is 2. In the same way, we can find the common ratio by dividing 8 by 4. So if we divide the second term by the first term, we will get the common ratio. In the same way, if we divide the third term by the second term, we will get the common ratio. We are going to apply what we've learned here to solve this question. The question is telling us that 3 minus a, 6 and 7 minus 5a are three consecutive terms of the GP. So it means that the common ratio will be equal to the second term divided by the first term. So the common ratio of this GP will be equal to the second term, which is 6, divided by the first term, which is 3 minus a, just as we have here. In the same way, the common ratio is also equal to the third term divided by the second term. Just as we have here, we have 8 divided by 4. So in the first case, the common ratio is equal to the second term divided by the first term. So that is what we have here. The same common ratio is also equal to the third term divided by the second term. So here we can say that the common ratio is also equal to the third term, which is 7 minus 5a, divided by the second term, which is 6. Now we can see that the common ratio in the first instance is the same as the common ratio in the second instance. So when we come here, we can equate the common ratio in the first instance to the common ratio in the second instance. The common ratio in the first instance is 6 divided by 3 minus a. The common ratio in the second instance is 7 minus 5a divided by 6. So we have 6 divided by 3 minus a is equal to 7 minus 5a divided by 6. We have our equation. We can solve for the value of a. This is an equation that involves a fraction. So we find the LCM of the denominators of the fractions and multiply it by each term in the equation to cancel out the fractions. The denominator on the left hand side is 6. The denominator on the right hand side is 3 minus a. In the videos on algebra, we learned that if the denominator of a fraction in an equation contains a variable, then the LCM of the denominators will be the product of the denominators. So here, since one of the denominators contain a variable, the LCM will be the product of the denominators. So the LCM will be 6 times 3 minus a. So we multiply the term on the left hand side by 6 times 3 minus a, and we multiply the term on the right hand side by 6 times 3 minus a. And this will give us 6 times 3 minus a times 7 minus 5a divided by 6 is equal to 6 divided by 3 minus a times 6 times 3 minus a. So we are going to have 6 will cancel 6 and 3 minus a will cancel 3 minus a. So this will give us 3 minus a times 7 minus 5a is equal to 6 times 6. So we have 3 minus a into brackets, 7 minus 5a is equal to 6 times 6. We open the bracket. 3 times 7 will give us 21. 3 times minus 5a will give us minus 15a. Minus a times 7 will give us minus 7a. Minus a times minus 5a will give us plus 5a squared. 6 times 6 will give us 36. Minus 15a minus 7a will give us minus 22a. So we have 21 minus 22a plus 5a squared is equal to 36. I'm going to bring 36 over to the right hand side, and this will give us 21 minus 36 minus 22a plus 5a squared is equal to 0. 21 minus 36 will give us minus 15. So if we rearrange it, we will have 5a squared minus 22a minus 15 is equal to 0. This is a quadratic equation. To solve this quadratic equation, we will first have to factorize the quadratic trinomial on the left-hand side of the equation. In the videos on algebra, I explained how to factorize quadratic trinomial. So I'm going to go ahead with the solution in this video. So we multiply 5 by 15 and that will give us minus 75. So we are looking for two numbers that when you multiply you have minus 75, but when you add them you have minus 22. Those two numbers are minus 25 and 3. So I will replace minus 22a with minus 25a and 3a. So you have 5a squared minus 25a plus 3a minus 15 is equal to 0. Once again, I want to stress on the fact that I have explained how to factorize quadratic trinomials under the videos on algebra. So watch the video on factorizing quadratic trinomials for more information. Let's continue with our factorization. You have 5a into bracket a minus 5 plus 3 into bracket a minus 5 is equal to 0. And this will give us 5a plus 3 into one bracket, then a minus 5 into another bracket. So to find the values of a, we will first equate the first bracket to 0. So we will have 5a plus 3 is equal to 0. And this will give us a is equal to minus 3. Then we equate the second bracket to 0. We have a minus 5 is equal to 0 and a is equal to 5. So now we have two values of a. Remember that the GP given to us in the question was 3 minus a, 6, and 7 minus 5a. If a is equal to 5, then it means that the first term of the GP, which is 3 minus a, will be equal to 3 minus 5 since a is equal to 5, and this will give us minus 2. If a is equal to 5, the last term of the GP, which is 7 minus 5a, will be equal to 7 minus 5 times 5, because a is now 5. So we have 7 minus 5 times 5. 5 times 5 will give us 25. And 7 minus 25 will give us minus 18. So it means that if a is equal to 5, then the GP, the geometric progression, is minus 2, because the first term, which is 3 minus a, will give us minus 2. Minus 2, 6, and the last term is minus 18. If the GP is minus 2, 6, minus 18, then the common ratio will be equal to the second term, which is 6, divided by the first term, which is minus 2. So we have 6 divided by minus 2, and this will give us minus 3. So this is when a is equal to 5. Now, let's consider when a is equal to minus 3 divided by 5. If a is equal to minus 3 divided by 5, then the first term, which is 3 minus a, will be equal to 3 minus a is now minus 3 divided by 5. So we have 3 minus 3 divided by 5. And from algebra, we know that this will give us 3 plus 3 divided by 5. And 3 plus 3 divided by 5 is equal to 18 divided by 5. We know that the second term is 6, but the third term is 7 minus 5a. Now we know that a is equal to minus 3 divided by 5. So 7 minus 5a will be equal to 7 minus, into brackets, 5 times a, which is minus 3 divided by 5. And this will give us 7 plus 3. Since 5 will cancel 5, so you are going to have 7 minus 3, which is 7 plus 3. 7 plus 3 is equal to 10. So this means that if a is equal to minus 3 divided by 5, then the GP will be the first term, 3 minus a. We know that 3 minus a is 18 divided by 5. So 18 divided by 5, then the second term, which is 6, and the third term, which is 10. Now, if this is the GP, then the common ratio will be equal to the second term, which is 6, divided by the first term, which is 18 divided by 5. From fractions, we know that this will give us 6 times 5 divided by 18. 6 times 5 divided by 18 will give us 5 divided by 3. So we can see that when a is equal to minus 3 divided by 5, r is equal to 5 divided by 3. And when a is equal to 5, r is equal to minus 3. In the question, we were told that r is greater than 0. That means that r is positive. From these two options, we can see that for r to be positive, a should be equal to minus 3 divided by 5. Because when a is equal to minus 3 divided by 5, r is equal to 5 divided by 3, which is a positive number. But when a is equal to 5, r is equal to minus 3. So since r is a positive number, then it means that the value of a is minus 3 divided by 5. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the common ratio of a GP. Bye-bye.